Hello. Hello everyone. This is the part 3 of our introduction webinar. Hello everyone. This is the part 3. Oh, sorry, I will mute the sound. Alright, so today I hope to make a little bit shorter stream than the last one. And the topics for today will be the configuration tool. That's actually not a MotionBuilder tool. It's a standalone application. But this one, I guess, would be great to demonstrate from the very beginning. But anyway, it's worth it to show. And also I would like to introduce a Sprite sheet solver, the calculate normals solver, and some image-based lighting shader and eye shader. So that's what I would like to share for today stream. So yeah, let's start. Alright, so this one tool you can find on GitHub. There is the repository called this one, MotionBuilder configuration application. So basically, let's start this application from GitHub. So I downloaded the version locally. Alright, so this one is the tool. And this tool is the helpful tool to configure environment variables for MotionBuilder. If you know nothing about the environment variables for MotionBuilder, let me introduce you something. So you need to go to your environment settings, environment variables. So these environment variables I'm using for compiling plugins. So this one is used in a setup to define where actually MotionBuilder is located, so that I can use this path and take the Open Relative SDK from it to compile plugins. So this one at the MoPlug external libraries is located, but this one is something that we need to know actually. So MotionBuilder plugin path and Python startup, it's the two environment variables that MotionBuilder is using when doing the start. So if you put here a path, and you also can separate with a semicolon several paths, then MotionBuilder will use and look for some plugins from these folders. So you don't really need to copy files directly into your, let's say, program files, Autodesk MotionBuilder, bin, x64 plugins folder. So yeah, it's true, like this is the default directory, and if you put your new plugin there, or if, for example, you, let's say, OpenMobu, so there is the precompiled version in bin, and we can choose a version, take this kind of DLL and put into your plugins directory. So in that case, MotionBuilder start using it, and also it would be nice to put there the shaders as well. But on opposite side, we can set up environment variable, and then MotionBuilder will use this kind of custom directory to load plugins from it. And the same for Python startup. Basically, if we define environment variables with a custom directory, it will also, MotionBuilder will use it. Yeah, we can do that manually, but this is the simple tool that I've created. This one, configuration path, could help you to manage all your directories. And as usual, like the plugins, they couldn't be shared between MotionBuilder versions because of different versions of Open Relative SDK. It's not like Python that you can run from MotionBuilder to MotionBuilder, mostly without any changes. But in plugins, it's a bit different situation. So for me, it's quite. So yeah, I'm obliged to change quite often different packs. And if, for example, I work on some in-house, development, I also need sometimes to take off plugins and then include other plugins. Yeah, so that's why how we can do this. We can put here, like, if we refresh, then the configuration path application automatically will read something which is already assigned, but I have nothing assigned. So that's why I just go to add and choose, let's say I want to use MoPlugs, binary, x64 plugins. So I select the path, and if I put the checkbox and apply, so then this program will automatically set up environment variable for me, so that next time I start MotionBuilder, it will load plugins from this directory. So let's go one more time to environment variables, and let's see. So now there is the plugin path with already assigned value. And if I put several paths here, it will also use it. So this is how this application what this application is for. So I already have here some predefined paths. So I put checkboxes here to do a startup, and also startup for Qt4 tools, because the new MotionBuilder 2019 now using Qt5, so I split into different folders, something which is related to Qt. So then I apply, and on my current, so this is actually OpenMobu. So now I'm running MotionBuilder. Oops. And it's trying to run 2019. Why? It's not the correct path. Okay, let's check. Yeah, this is not the correct folder. So 2018 MotionBuilder couldn't open 2019 plugins. So basically this one is not correct path. I need OpenMobu 18 as I'm running right now. So when this label disappears, then environment variables are done. So let's run MotionBuilder. And action. So we have Python tool like restructuring, which is part of OpenMobu. So that is fine. We also can have post-processing, which is also part of OpenMobu. So yeah, everything works well. And if I just refresh and then disconnect these tools, apply, and when it's ready, I run MotionBuilder one more time to check that now I don't have this tool connected. So there is no any more restructuring tool here, and there is no more post-processing. So that's easy. And one good trick about this is that actually in GitHub there is a special GitHub desktop application. So I have here my main repositories regarding MotionBuilder is the OpenMobu and MoPlugs, and each repository, yeah, by the way, there is a kind of issues section where you can create a new issue if you find it, or even if you have kind of cool idea or something that you would be nice to have in this extension pack, you also can create a new issue. So feel free to take part in development. Alright, so basically we have this repository that's from time to time I'm updating, and it's not convenient to manually copy these files, download and copy into a specific folder. Instead of this, we can open a desktop. If you install this GitHub desktop on your computer, then you will have this application, and you have different, like here for example, I have different repositories. And if you fetch origin, it will download updates from the website automatically. So you will have on your local default path that I have here, it's in documents, the GitHub. So for example, the MoPlugs, there is the folder with the plugins. And then with my configuration application, or you can manually just set up your environment variable to use these GitHub folders. So that means you can always very quickly catch up the updates and then run MotionBuilder and use it. So this is very kind of convenient way to deal with the extension pack. Yeah, so hope these notes will be useful. And another thing that I would like to talk about for today, so I think that's all for configuration application. And another thing is the spreadsheet solver. So now let's run MotionBuilder. For spreadsheet solver, it's a part of MoPlugs extension pack, and in MB scenes there is the several textures available. So the spreadsheet, it's something that that is widely used in the game development. Oh, why it's black? Where is the texture? Alright, it's here. So it's widely used in game development. Basically, it's the video which is baked into one texture that is played frame by frame. Like in MotionBuilder, originally you don't have any kind of possibility to play these sprites as animation, for example. So you always need to have a video file. But you can locate a lot of cool effects from games just for free on the web, and then use in your project for if you're doing kind of previews. So with the spreadsheet solver you can start using these kind of atlas textures as well. So let me show how it works. So we go and add video plane. That's what we have right now. Then for this video plane, the spreadsheet solver works well with the projector mapping shader. So we can go to shaders to create a new projector mapping shader from one side, or we can directly from the context menu we can replace with the projection mapping shader. And then in the solvers there is the sprite sheet solver. So we drag and drop into the scene. And it's also helpful, like from one side we can connect, you need to, this one solver, you need to drag and drop your scene geometry video plane into spreadsheet solver to connect them together. Another possible way is register or unregister your model from the context menu. So we can register a model, then let's activate spreadsheet solver, and here we go. So we have animation played. So actually what it's doing here as the internal thing is that I think it's on our model. Now we have a lot of properties here, and we have property for the texture translation and scaling. So basically in internal evaluation what it's doing is it's taking this texture, and we know that in our texture as usual we have this kind of translation and scaling. So it's automatically depends on how columns and rows it has and how you can specify this manually. So by default it's 4x4. So here in the texture we have this 4x4 properties. So it's automatically recognize each frame and compute the correct translation and scaling to have an offset frame by frame, so that you have this animation. If for example I would like to have another texture, so let's say this kind of explosion, and I put in the diffuse, you see that it's not playing correctly because in this texture there is the 4 columns but 5 rows, so we need to change a bit. So there are no properties right now because it's a new texture, but we always can create properties with the context menu add spreadsheet properties. Now we have this 4x4, we need 5 columns, and to use this update we need to turn off active and then turn back. So now we have this correct number of columns and properties to play this sprite. Then what we can do here, we can always put kind of transparency, so we have this effect, Then from the model properties in the video plane, we can always control, let's say, the speed to make it really faster. There is also a way that we can connect this playback from the relation constraint. So there is a kind of checkbox to use trigger and to not have a loop play. So it will be play only once. And when the trigger is more than 0 from relation constraint, for example, you press a button or you do any kind of other action like here, so we just play this animation. So it's kind of interactivity that we can have. Another thing how it could be playable is that on scaling. So when we scale down the plane to 0, and then when we scale down back to 1, it will automatically play animation. So that's one more feature that we can use to have this effect on impact when the sprite animation will be played. Alright, and also with these planes we can duplicate if you want several. Let's duplicate, and we need to register in Sprite sheet solver. We can make it play faster as well. But also we can make a billboard from it using the sprite aim constraint. So if we select our planes, put the constraint objects, and then snap, so we will have this kind of billboards. And we also can have a different type of billboard, not a cylindrical, we can put the spherical, so we will have a look from different side. Yeah, so this is actually sprite sheet solver that could be used for. Alright, so let's go to the next thing for today that I would like to introduce is the calculate normal solver. This is quite important thing if you want to improve the quality of your animation, facial animation especially, or something based on blend shapes. Because originally, if you deform something in MotionBuilder, there is no any kind of recomputation for normals. So let's say we have this sphere with the simple animation of impact, like we have here impact of shape globally. So we have this kind of push inside, but there is no any kind of visual. If we have a look from the top, we even couldn't recognize that something happened with this sphere because there is no any kind of reevaluation of normals. And to have this kind of improvements, we have a special calculate normal solver, so that I hope it will work fine. We drag and drop the model and connect to affected models. So now if we make it one more time, we really see that there is a kind of deformation happened here. So you see how really it gives a very good quality impact. And this is not only for skeleton animation, but also for your blend shapes. So you really can improve the quality of how your shape deforms and how your lighting is playing on your surface with this calculate normal solver. Yep, that's it. And the last thing for today that I really would like to share is the image-based lighting and eye shader. The eye shader is the kind of realistic eye shader. So these examples, they are located in MoPlugs repository in MB scenes. So you can locate it in render features. There is a test eye shader. There is also the archive with the Cerberus gun, which is using image-based lighting shader, and I will show it right now. So let's open test eye shader. So this is the basically kind of realistic eye shading with the parallax effect. You see that the iris inside is deformed whatever I'm looking from the side in profile. So there is also what we need to assign here is several textures. We have the color, we have the normals, so there is no any kind of a lot of customizations that we have on the shader. So if you want to customize your eyes, you probably need to do everything quite in the similar way of UV set, just to override existing, for example, this one is the reflection that we see inside the eye. It's this one, a reflection texture. There is also kind of diffuse reflection that we can override. And this one is actually eye shader, which is you can find in shaders. And where is it? Ah, sorry, this one, eye shader. Yeah, so it's here. And the image-based lighting, it's these shaders is the image-based lighting, and there is also skin shader. So let's open the test scene. It's this one. So like the modern practice of image-based lighting and the physical-based render is when you have your, as usual for many game engines, I think almost all the game engines except MotionBuilder, which is not actually game engine but it's really outdated. Yeah, but now you can use the modern way of model render in MotionBuilder as well. So like we need for our material albedo texture. It's better to use DDS if you have possibility, because like as I told in the first part, the DDS is quite of native format. It will not have any kind of intermediate part of computation. It will directly go to video memory, and also you can include MIP maps on your DDS, which will give you less jittering on the final result. So yeah, we need albedo, but then in specularity channel we need to assign the special texture. It's this one. So in alpha it's kind of cavity or ambient occlusion, I think, and RNG channels it's the metal and roughness, but it's a common practice on every game engine nowadays, so you can read a lot of cool material about this on internet, about the image-based lighting and how to set up material actually. So, and also we need a normal map to have finally this kind of cool effect. You see, we have a real kind of interesting specular, and this model is lighted not from the lights, this model is lighted from the special cube map light. And to support cube maps, I've created, you can see it in elements. There is a special element called object cube map. And for image-based lighting we need two of them in the scene. We need the object cube map with the diffuse texture. When it's loaded we have cube map ID, so then I can bind OpenGL texture from this cube map ID. So basically with the cube map object we have now in MotionBuilder support for a real cube map textures, which is a 6-side texture instead of simple 2D. And here I've loaded actually this one from this Cerberus FBM. There is inside diffuse texture cube map, and I need one more cube map, which is the specular. So then if I go to assign shader, in shader I have this environment property where I need to assign my cube map. So I'm connected like here, and specular I'm connected here, but also I need BERDF. What is for, if you want to know in details, you can read a lot of cool material on internet about this. I will not really go deep inside this description, but basically if we go to MB scenes, this texture looks like this. So it's evaluation of lighting on normals, which I've added. This is simple 2D texture I've added into connected here in BuilderDF. And yeah, that's it. What we need actually, there is also kind of emulation of backlight and rim, which we can add here as well if we need. And we have this cool effect. And I also applied on the mesh, on the simple, this is the sample model mirror, which we, last streaming I was used quite a lot. And for mirror texture, it's only one texture actually, it's albedo, so we have only diffuse texture. There is no any kind of roughness and metalness texture, and there is no any kind of normal map texture. But what we can do in this way is we still want to have some cool effect. So the trick is on the material, this one, there is a small plugin that we need to create two custom, or we can do it just from the editor on the custom properties. We need this number, two custom properties, metal and roughness. If on material we have, so I select the material and just add these two properties. Now I have it here. So when I have these properties, I can control the metal parameter and roughness parameter, instead of connected texture. Even if I don't have to connect texture, I can still control these parameters somehow. And yeah, so we have this kind of effect on the mesh with the image-based lighting. We still have kind of image-based lighting reflection, this kind of specularity applied. And this is skin shader connected, so we can apply maybe this skin shader also on eyes. I'm not sure if it will be a good idea, but why not? And on eyes I have this body material, and for body material I want to do the same, so I just, if I don't have this texture, I just put there two custom properties and assign some values. So now I have quite cool view. I can do the same for the body. And what material we have here? This one. Do we have custom properties? No, it's a body, sorry. This one is material. Alright. Just a bit less roughness. These parameters are a bit tricky, but anyway, you can like tweak it. Yeah, so this is image-based lighting, which can give quite very cool looking models inside your MotionBuilder with the new technique of physics-based shading and textures that widely used in games right now. And then we also can do composition with apply kind of interesting shadow and yeah, post-processing on top. And that's almost all for now. There is one more thing that I would like to show, just a little bit demonstration. There is also plugin for columnplay. So this one. There is also a device, voice device. I will connect right now my microphone. I hope you still can hear something what I'm talking. I can. If there are some levels, yeah, just a little levels I have here. If we go to relation constraint, maybe I need to, yeah. So the voice, my level voices from MotionBuilder, from the microphone, they are connected directly to the display's value of the constraint. So this one, the constraint column play. So I think I need to put kind of multiplication here. Let's put a scale and offset. Oh, not right now, sorry. Okay, so let's multiply. And yeah, we have kind of values here. So the signal is not very nice, really following. There is kind of just noise, I think. But anyway, I hope you hear something from the microphone right now, what I'm talking about. I hope the microphone works well. Maybe just the microphone is blocked by the recording system. That's why I don't have a good signal. I'm not sure. But anyway, the idea of this constraint was the kind of interactive play. So there is the cubes. In total is the 192 cubes and the constraint. And constraint basically, it also you need to connect a 3D curve. It's a custom curve that 3D path that I paint. And whenever I move this curve, all the cubes which is just above the curve, they use my input display value to rise up. But all other cubes, they have a little bit of a soft influence to also trying to jump and rise up with the levels. And yeah, and globally we have this kind of effect of levels playing by music. So that was used on the musician show interactive play with a virtual character on the stage. So yeah, but now it's available just also like other plugins for free with the open source. But that's like a part of history, this constraint column play. Yeah, we can define connect distance as well to have more connection from the main influence cubes to other cubes. So that's it for now. Put some like if you really like today's webinar and you find it useful. And yeah, possibly I will create some other next webinar. So follow the channel and you will receive some notification when it will be the next webinar. There is also a Twitter and Facebook page, because there is still a lot of interesting things that I can show and introduce. Yeah, and have a good evening. Thanks for watching.